Hello, this lesson is 4.2 Areas of Triangles. The essential question is, how can we determine the formula for the area of a triangle using what we know about the formula for the area of a rectangle? So notice in this whole unit of finding areas of different polygons, we keep going back to what we know. And so if you look at page 81 in your Record and Practice Journal, the first activity that I'm going to have you do is activity 1. And there's an A and a B. And so what I want you to do is I want you to get, right, you're going to draw any rectangle, right? So it says draw any rectangle on a piece of grid paper. And I'm going to cover up the activity B. We just want to do one thing at a time. And when you draw your rectangle, it's easier on grid paper because you just count the squares to find your length and your width. But if you only have lined paper or blank paper, then you can just use a ruler and you can measure, or you can make, right? If I was using a ruler, I wouldn't want to deal with fractions, right? So I would probably measure, maybe this is 1 inch and maybe this is 3 inches. So if you're using paper that's not grid paper, then make a nice friendly rectangle that has an area that you can establish before you even draw it, right? So you can measure it and make it a whole number measurement. Okay, and then once you have your rectangle, then what you're going to do is you're going to create a diagonal. Remember, the diagonal goes from corner to corner. So you create a diagonal and then you're going to cut the whole thing out, right? You already know what the area of your rectangle is, or you should have calculated it. And then you cut out the rectangle and cut half of it. Okay, when you cut half of a rectangle, you now have a triangle. And notice there are two equal triangles. And so what I want you to see is that when you look at the area of the triangle, because it's half of the rectangle, the formula for a triangle is length times width divided by 2, because all you're doing is basically taking the area of a rectangle and cutting it in half. Okay, so this may be what yours looks like, right? So there's a big rectangle. This time I drew the diagonal in the other direction, but you're still noticing that you're making two congruent triangles when you cut a rectangle in half. Okay, so on the same page, there's activity 2. On the same page of your Record and Practice Journal. This time you're going to make a different triangle. What it says is do not use a right triangle, right? So what I don't want you to do, that's a little big, I don't want you to do a triangle like this that has a right angle. So notice the triangle that they're showing as an example, it's not a right triangle. If you go from the top to the bottom, you see the perpendicular side there, but that's not an angle in the triangle. And so this time what I want you to do for activity 2 is, and I'm showing you that you can complete the activity after class. It might take a little bit too long, but what you can do is you can take a piece of paper, and if it were me, I would probably draw the triangle down here, right? So I would actually put the triangle on the fold, and then when you cut out the triangle, the folded part needs to be cut as well. But when you cut on the outside from here to here, it's an easy way to make two identical triangles. So this time, instead of starting with a rectangle and cutting it in half, you're starting with two triangles and you're going to be putting them together. So here's what I want to show you. The video is already started, so I'm going to make this a little bit bigger. All right, let's make this bigger, and let's go ahead and play the video. There's my two identical triangles, and notice I flip one over, and then I twist it, and I put it together with the other triangle, and bam, you can see I just made a parallelogram. I didn't make a rectangle, I made a parallelogram. But you know a parallelogram can be made into a rectangle, or the rectangle is the same thing as a parallelogram. Okay, so I'm going to shrink that, and I'm just going to show you the instructions here. Said put the fold as the base, or the bottom of your triangle, and then you can cut two triangles at a time and make a parallelogram. Now, the parallelogram, right, to find the area of a parallelogram, You find the base and you find the height. And so if I think about the area of this parallelogram that I drew, it is, let's see, make sure I'm on the pen. I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8. So my base is 8, or I could have actually counted down here. And then my height, but it's the same picture, so I'm counting 1, 2, 3, 4, 5, 6. So for my parallelogram, my height equals 6 units and my base equals 8 units. And when I find the area of the whole parallelogram, it's 8 times 6. But then if I'm just taking half of it for the triangle, it's 8 times 6 divided by 2. So if you put two identical triangles together, depending on the shape, you could make a rectangle, but this one is a parallelogram. Okay, so this brings us to the key idea, right? The area of a triangle. I put a red star next to this. I want you to write the words and the algebra, and I also want you to draw the picture. Now, you're going to notice there's two formulas. The second formula, right, this one is one that I added. The book only shows the left one. But I want you to think about what we did in the first activity, where you took a rectangle, base times height, and you cut it in half to make a triangle. That's what you're doing when you multiply base times height and you divide by 2. Now, with the first formula, when you multiply by 1/2, right, when you multiply by a half, that's the same thing as dividing by 2. But sometimes it makes it easier to use this formula because you can multiply 1/2 times the base first or 1/2 times the height first. And I'll show you what I mean with this example down here. We can be strategic and make the numbers so they don't get so big and crazy. Okay, so pause the video, write the words and the algebra and the picture. And then I've got this to show you because I want you to always remember how you find the base and the height, just like with a parallelogram. The height is a line from the top to the base, and it must be perpendicular to the base. So I want you to notice right now. Now, I kind of didn't give you the whole story because I should always see that little corner symbol. That means it's perpendicular. If you don't see that, well, we can kind of assume it's perpendicular, but if you see that little square in the corner, then I know for sure that the 3 is parallel to the 8. Okay, so I want to point out that this 5 centimeters is the side of the triangle. I'm going to call it a slant height, right? Because it's slanted, and it definitely is the length of that side. And then this is also a slant height, right? But notice the formula doesn't say anything about a slant height. It says the height. So I'm going to cross that off and cross that off. I don't use those two numbers in my formula. I need the height of the triangle, which is from the top to the bottom, and then I need the base. So right now I know that the base equals 8 and the height equals 3. So remember, you're looking for the two numbers that are perpendicular to each other. Okay, next. Now we've got some examples, and we're going to start off with some easy examples, right? There's only two numbers there. You can see the perpendicular sign. Now, honestly, I could rotate. I could do this. It's hard. It gets confusing about which is the base and which is the height at this point. Because I could rotate the triangle this way, and now it looks like the 8 is the base and the 5 is the height. And then if I move it back to where it was, okay, now it looks like the 5 is the base, right? The base is the bottom, and the h is the height. It doesn't really matter if you just have two numbers, but because this one's down here, I'm going to label it base, and I'm going to label this height. Now remember, the more times you write the formula, the easier it is for your brain to remember it. So I'm going to write area equals base times height divided by 2. Okay, I forgot something that I wanted to mention, which was on this example here. Notice if I go to find the area, I could multiply 8 times 3 and then divide by 2. But if I want to make my numbers smaller, I could do the 1/2 times 8 times 3. Because when I do 1/2 times 8, right, half of 8 is 4. And so now I know I'm just multiplying 4 times 3. And if I multiply the 8 times 3 first, I get 24 divided by 2 is 12. It might be easier sometimes to multiply by 1/2 instead of dividing by 2 after you've multiplied the base and height together. Okay, so here we go. These numbers aren't too big. I think I'm going to use the formula like this. So what I want to do is once I have my values identified, right, you could highlight if you want to make sure that you're plugging in the numbers the right way, right? So I could highlight the height here and the height here, and then I could pick a different color, orange, and I'm going to highlight the base, come on, pen, in this color. Okay, sometimes I do that just to make sure I'm putting in the right numbers. Okay, the base is 5, so I write 5 times 8 divided by 2, right? I'm going to do the top of the fraction first. 5 times 8 is 40, divided by 2 equals 20. So the area of this triangle is 20. Now remember, the units are still square inches. And this time I left out the 5 inches times 8 inches. But units are squared because a triangle has 2 dimensions, and I'm counting the square inches inside. All right. So now we get to some OYOs. These are the simple triangles. There's only 2 measurements. I want you to pause and try these on your own. I'm going to label this as the base, and this is the height, and this is the base, and this is the height. And then I write the formula. Area equals base times height divided by 2. And then I'm going to plug in the numbers. I get 11 feet times 4 feet divided by 2. So what I end up with is 44 divided by 2, which equals 22 feet squared. Oops, I should put my feet squared right there. Okay, so the area of that triangle is 22 feet squared. All right, so keep going. Area equals base times height divided by 2. You know, I guess I'm just multiplying by 10, so that's not so hard. I plug in 22 meters times 10 meters, and then I'm going to divide it by 2. 22 times 10 is 220. I get meters squared. Let's fix that. Meters squared, and then I still need to divide by 2, and I get 110 meters squared. Okay, so now I've got, it's not any harder, but I just want you to see for this triangle, the hard part is when people look at this, right, they're thinking that maybe, oh, this is all one picture. Okay, so I can't twist it. That's all right. And sometimes people want to count this, right? People want to count this as the base. Well, for one thing, there's no measurement to that side. So if this was the base, then what I would need is I would need the height from here to the perpendicular to the base, right? So that's the idea of we use the numbers that were given, and hopefully we're given enough information. So I'm going to call this the base, the 12, and then notice that from the top of the triangle down to the bottom is 9 meters. That is the height. It is the measurement that is perpendicular to the base. And then I write my formula. Area equals base times height divided by 2. I think for this one, I'm going to do the 1/2 base times height. Okay, so let's do one where I show 1/2 times base times height. And so I'm going to plug in 1/2 times 12 times 9. Now remember, when you're multiplying 3 numbers together, you can only do 2 numbers at a time. So I'm going to multiply 1/2 times 12 over 1, right? You could just do mental math if you know that half of 12 is 6. But I'm just going to remind you of when we multiply fractions, We multiply the numerators, we multiply the denominators, but before we do that, we look to do some cross-reducing, right? So I want to divide out, oops, that should be a times. I want to divide out a 2. 2 divided by 2 is 1, and 12 divided by 2 is 6. So the answer to the first multiplication is 6. So I have 6 times 9, and I get 54. And I left out the units, so remember it's meters squared. Okay, so now the reason that I multiply by 1/2 is because I didn't want to do 12 times 9 and then divide by 2, because I felt like that was getting to be a little bit of a bigger number than I wanted to work with. Okay, so now you guys have one more example that's sort of like the one that I did. Pause this, right? Label your base, label your height. On your paper, remember what I asked you to do. You're writing the base equals 15 centimeters and the height equals 8 centimeters. And then you're always going to write out the formula. Area equals 1/2 base times height. And then I plug in the numbers, 1/2, 15 times 8. Okay, I'm glad I have one like this that I can show you. If I try to multiply 1/2 times 15, 15 is an even number, right? So half of 15 is what, like 7.5? I really don't want to have to deal with a fraction or a decimal. So remember the commutative property. The commutative property says I can commute the 8 and I can put it over here. So now I'm going to do 1/2 times 8 over 1 and then times 15, right? The reason I did that is because 8 is an even number, and when I do my cross reducing, I get 4, right? Half of 8 is 4, so I end up with 4 times 15, which is 60 centimeters squared. So that's why I'm strategic when I start doing the math, right? I don't want to just start multiplying numbers and not think about what makes my life easier. Okay. And now, example 3, right? So now I have to throw in one that makes you have to think a little bit because there's 3 numbers and we know you're only going to be using 2 of those numbers. So I want you to go ahead and pause the video and make sure that you can identify which of those 3 numbers is the height and which is the base. And then I'll show you with this one, right? If I take this shape and I turn it around, okay, now it looks like that triangle that I'm used to seeing where this is the bottom or the base and the height goes straight up perpendicular from the base, right? Gonna put it back there. Okay, so it looks like the height is, the base is the 16 meters and the height is 6 meters. And then this is a slant height, right? Because it's the side of the triangle. It's not the base and it's not the height. So I'm going to cross this off. I can't use the slant height. All right, so here's 2 more Oyos. You're going to try these. You're going to pause the video and try these on your own. I'm going to point out that you've seen this triangle before, right? I did it on purpose to make it easy. That's the slant height. That's the slant height. This is the base. This is the height. Area equals 1/2 base times height. 1/2 times 8 centimeters times 3 centimeters. 1/2 times 8 is 4 centimeters times 3 centimeters equals 12 centimeters squared. All right, and the next one. I see, right, I'm looking for this perpendicular symbol. I see the 2 measurements that are perpendicular to each other. Oh, that 10 is a slant height, right? It's the side of the triangle. I can't use that. 14 is my base, 8 inches is my height. I'm going to use the area equals 1/2 base times height. So it's 1/2 14 inches times 8 inches. And I can do the 1/2 times 14 and I get 7 inches times 8 inches. And I get 56 inches squared. Okay, so the last thing I want to show you is just something that will make you think a little bit about sort of some problem-solving strategy. So the question says, how can we create a triangle with an area of 12 square units? So I want you to think about a triangle that has 12 square units, and I want you to think about the fact that a triangle is half of a rectangle, right? So if you have a triangle that has 12 units squared, the rectangle maybe that you started with when you cut half of the triangle, maybe that means the rectangle has to be 24 units squared. Oh, how can I make a rectangle that's 24 units squared? Oh, that's right. It's kind of like what we did when we started looking at what are all the combinations of two numbers that I can multiply together to get 24. Well, I can make a rectangle that's 1 by 24, or 2 by 12, or 3 by 8, or 4 by 6, right? So let's just go ahead and draw one that is, let's see, let's do 3 by 8. There's 3, and then I need to count, oops, I don't want to move that. Okay, so let's keep that where it is, and let's do another one. So now let's count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I'm doing this and this. Okay, so when I complete my rectangle, my length is 8 and my width is 3. And 8 times 3 is 24. And then when I draw a diagonal and I cut this rectangle in half, my diagonal makes a triangle that should have an area of 12 square units. Well, let's test the formula. Area equals length times width divided by 2. So my length of my rectangle was 8 times 3 divided by 2. 24 divided by 2 equals 12 square units. Cool. That's it. All I had to do was think about if I'm trying to make a triangle, I just need to double it and figure out the dimensions for a rectangle. Okay, good luck.